This section we will try to solve quadratic inequality. We will try to solve quadratic inequalities, polynomial inequalities, and rational inequalities. Okay, we did see our linear inequality in chapter 1. Okay, so in order to solve the quadratic, polynomial, and rational inequalities, here we have a 4-step. First step is that we have to rewrite the inequality with a 0 on the right side, and let's do that step on our first example. So here we have 2x squared minus 3x minus 2 greater than 0, and we already have 0 on our right side, right? So we can skip first step for this example. Next step is we factor the non-zero side. Okay, so this is our non-zero side. So this is our non-zero side, and we factor this non-zero side and find the zeros of each factor in the inequalities. Okay, so here we have this quadratic form. Now let's go ahead and factorize this quadratic form, and once we factorize, we find the zero of each factor. Okay, which method we use here? We use a AC method. Okay, so this is our A, this is our C. So A times C, that is 2 times 2, that is 4. Then we write down every pair of factors of 4. So we have 1, 4 and 2, 2. So these are the two pair of factor. We choose one pair of factors to rewrite negative 3x. Now which two numbers do we use? 1 and 4 or 2 and 2 to rewrite our negative 3x? You are allowed to add these two numbers or subtract these two numbers. We use 4 and 1. So what will be negative 3x equals to then? So we have 2x squared as it is. So we need to have a negative 3x, and we are using 4 and 1. So it has to be negative 4x positive x, okay, which is same as negative 3x, and we have negative 2 as it is greater than 0 as it is. Okay, now we have 4 terms. Let's make a pair of first 2 terms and pair of last 2 terms and look for the common terms. So in first 2 pairs we have 2x as a common factor. If we factor out 2x from 2x squared, we have x. If we factor out 2x from negative 4x, we have negative 2 plus in the last 2 terms. So what do we factor out? 1 is always a common factor, right? So we can factor out 1. So if you factor out 1 from x, we have x. If you factor out 1 from negative 2, it's negative 2 greater than equals to 0 as it is. Now here we have x minus 2 factor, x minus 2 factor. This is a common. So let's factor out x minus 2. So let's take this out, which is common. Now we have remaining 2x plus 1, and it will be next factor 2x plus 1 greater than 0. So in second step, we factorize this non-zero side. Okay, so we have these 2 factor. Next we find the 0 for each factor. Now let's take first factor. So for what x value this factor is 0? 2, right? So 2 is a 0 for this factor. Now for what x value this factor is a 0? For what x value 2x plus 1 is 0? Negative 1/2, right? Okay. And if you need help with that, what you can do is that you can write down this factor. So write down this factor, set it equals to 0, and you solve this equation. So you subtract 1, 2x equals to negative 1, divide by 2, and you get x equals to negative 1/2. This is also you can find if you need help, okay, to find the real zeros. Now let's go to the next step. So we factorize and we have the 0 of each factor. Now the resulting zeros divide the x-axis into multiple intervals. So x-axis means our number line, okay. So we have a number line, and we use these zeros to divide our number line into different sections. So we have 2 and we have negative 1/2. So negative 1/2 has to be on the left side of 2, right? So let's say 2 is here and negative half should be on the left side. It's a negative number. Okay. So we are using the zeros to divide our number line. Okay. So that's our next step. Make a table and test the sign of the inequality in each of these intervals by choosing appropriate test values. Okay. Now we have 3 sections. Okay. So we have this interval, right? So we have this interval and we have this interval. So we have 3 intervals. Now out of these 3 intervals, we have to find the correct interval as a solution for this quadratic inequality. Now at first, what about 2 and negative 1/2? Are these two solutions for this quadratic inequality? How do we know this is solution or not? Now here in our inequality, it is strictly greater than, right? So there is no equals to. No equals to means these two are not the solution for this quadratic inequality. Not solution means we use a open circle at 2 and open circle at negative 1/2. Or you can test it. You replace every x by 2. So we get 2 times 2 square 4. That's 4 times 2 8. 8 minus 6 2. 2 minus 2 is 0. 0 greater than 0. That is not true, right? So 0 is equals to 0, and because of that this 2 and negative 1/2 is not the solution. So we have an open circle. Okay, and you can check. So if you have a quadratic or a polynomial inequality, if you have greater than equals to, less than equals to, you are using a closed circle. It means those real zeros are the solution. If you have strictly greater than, you use a open circle. Closed circle means we use a bracket. You all know open circle means parenthesis. And this is the case when we have quadratic or a polynomial inequality. Now let's take a number from each interval. Now what number do you want to take from this first interval? What number do you want to test? Just pick one number from this green region. Negative 2. Okay, so negative 2 is here. Now is negative 2 a solution for this inequality? So what do? We take that inequality. Okay, so our inequality is 2x square minus 3x minus 2 greater than 0. We replace every x by that testing number. Okay, you do not need to show work here. You can do it on your calculator or on your head. So let's do this. So negative 2 square is positive 4. Positive 4 times 2 is 8, right? Minus negative 3 times x is negative 2. Negative 3 times negative 2 is positive 6 minus 2 greater than 0. So 8 plus 6, 14. 14 minus 2, 12 greater than 0. Is it true or false? 12 is greater than 0. It's true, right? It means this interval is solution, one solution. Now let's check our next interval. So what number do you want to pick in between negative half and 2? 0, right? It's the easy one. Now if our testing number is 0, is the inequality true? So let's replace x by 0. So 2 times 0 square is 0 minus 3 times 0 minus 2 greater than 0. So we have negative 2 greater than 0. Is it true or false? This is false, right? So it means this interval is not solution. Now we have one more. So let's pick 3, or you can pick any number. So if we pick 3, we have 2 times 3 square 9 minus 3 times 3 9 minus 2 greater than 0. So that's 18 minus 9 minus 9. Oh no, that's a positive 9. So 7 greater than 0. It's true, right? So it means this interval is solution. So our solution for this quadratic inequality is from negative infinity to negative 1/2. Open circle means parenthesis, or which is union from 2 to positive infinity. This is the solution for this inequality. Okay, any question up to here? can I start the next one? Okay, so this is our quadratic inequality, and quadratic inequality is also a polynomial inequality. Okay, and if you have any polynomial inequality, so this is how we solve. Now the next here we have this inequality. Now what kind of inequality is this? This is the rational inequality. Okay, so this is our rational inequality. So let me rewrite that. So we have x squared minus 9 divided by x plus 5 greater than 0. So first step is that we make 0 in one side, so which we already have here. Okay. Now second step, we have to factorize our numerator and denominator. Now since this is a rational inequality, we have to factorize numerator and factorize denominator. Okay. Now how do we factorize x squared minus 9? So we can rewrite 9 as a 3 square, right? We have x plus 5 as it is, greater than 0. Now, what we have? We have a difference of 2 square term. So if we have a difference of square term, so if we have a difference of 2 square term, what are their factor? A plus b times a minus b. Okay, so you rewrite those terms as a perfect square, and the sum of those two terms times difference of those two terms. Now in our case, it would be x plus 3, x is a, 3 is b, times x minus 3 divided by. Now what about x plus 5? Can we factorize in a simple factor form, or it's in the simplest form? It's already in the simplest form, right? Because the degree is 1, so x, let's rewrite x plus 5 as it is, greater than 0 as it is. Okay, now the next we find the zeros of numerator and denominator. Now for each factor we find the zeros. Now for this factor, for what x value this factor is 0? Negative 3. So negative 3 is 1 0. For this factor, what is the 0? Positive 3. Now we have this factor. For what x value this factor is 0? Negative 5. Okay. Now we use these numbers to divide our number line. Okay. So let's draw a number line. So we draw a number line. Okay. And we are using the zeros. So this is negative infinity, positive infinity. So positive 3 is somewhere here, negative 3 is here, and negative 5 has to be on the left side. Make sure these numbers has to be in order. Okay. Now, out of these three non-zeros, which are the solution? Now let's start with negative 5. Is negative 5 a solution for our inequality? What happens if you replace x of this inequality by negative 5? You can just test here. Negative 5 plus 3, negative 2, negative 5, negative 3, that is negative 8. Negative 8 times negative 2, that is positive 16, divided by negative 5 plus 5, 0. 16 divided by 0. Is that even a real number? It's undefined. It means negative 5 is not a solution. Okay. So it's not solution means we use a open circle to exclude negative 5. So if you have a rational inequality, the zeros of the denominator are not the solution. Okay, so negative 5 is the zero of denominator, so this is not a solution, so open circle. Now what about our negative 3 and positive 3? Are these solution or not? Now let's replace our x by negative 3. So if our x is negative 3, this is 0, right? 0 times whatever we have is 0. So 0 divided by negative 3 plus 5, 2. 0 divided by 2 is 0. 0 greater than 0. That's false, right? Because 0 is equals to 0. So negative 3 is not solution. In the similar way, 3 is not solution. Okay? So zeros of the numerator depends on this sign. We don't have equals to here, so we have an open circle. Okay, but make this zeros of denominator is never a solution for rational inequalities, okay, but the zeros of numerator depends on this inequality sign. Now let's test each number, okay. So we have three interval, no, we have four intervals. So this is one interval, right? So this is our second interval, so this is our third interval, and we have one more interval, and we have to pick a number from each interval and test that number for this inequality. Okay, from here let's pick -6. Now is this a solution for our inequality? So you replace every x by -6. So -6 plus 3, that is -3, right? Times -6 minus 3, -9. -9 times -3 is positive 27. So we have 27 here. Divided by -6 plus 1, -1. So 27 divided by -1 is -27, which is greater than 0. Is it true or false? False, right? It means first interval is not our solution. So this is not the solution. Now let's take a number here. Let's take -4. Now each -4 solution for this inequality. So -4 plus 3, -1, -4, -3, -7 times -1, positive 7, -4 plus 5, positive 1, positive 7 divided by positive 1, 7 greater than 0, that's true. So second, this interval is our solution. Now let's pick a 0 here. Now each 0 solution for this inequality. So 0 plus 3, 3, 0 minus 3, -3. This is -9 divided by 5, which is negative number greater than 0. True or false? False, right? Because -9 divided by 5 is not greater than 0. Now what about the last interval? Let's pick 4. 4 plus 3, 7. 7 times 1, 7 divided by 9 is greater than 0. 7 divided by 9 is greater than 0. That's true, right? So it means this interval is solution. So our solution is the yellow region from -5 to -3, open circle means parenthesis, or the last interval from 3 to positive infinity. So this is our solution for this rational inequality. Any question? Now let's practice few more, and it will be from our review handout. Okay, we have more example on our review handout. It's gonna be page 4. Okay, and if you need review handout, let me know. I have one more here. So let's start with number 11. Okay. Okay, so here we have our polynomial inequality or quadratic inequality. What is the first step? We make 0 in one side. Now what side you want to make 0? Let's make right side 0. Now to make right side 0, we have to get rid of 6, positive 6, and for that we subtract 6 on both sides. So our inequality is 2x square minus 7x, 2 minus 6, that is -4 less than 0. So this is our first step, making 0 in one side. Second step, we factorize this non-zero side. Okay, since the coefficient of square term is not 1, we use a AC method. Our a is 2, c is 4. So a times c is 2 times 4, which is 8. Now we write down every pair of factors of 8. 1, 8, 2, 4. Out of these, which one do we pick here to rewrite -7x? It has to be 1 and 8, right? 1 minus 8 is negative 7. So our inequality looks like now 2x squared as it is. Now we rewrite negative 7x using these two numbers. So negative 7x is same as negative 8x plus x minus 4 as it is, less than 0 as it is. So we have a 4 terms. Let's make a pair of first two terms, pair of last two terms. In the first two terms, we have 2x as a common factor, and we have x minus 4. In the last two terms, we have 1 as a common factor, x minus 4 as it is, less than 0 as it is. X minus 4, x minus common. Let's factor out. X minus 4, 2x plus 1. So this is our next step, factorizing the non-zero side. Now, once you have the factors, we find a number that make each factor 0. Now, for what x value this factor is 0? 4, right? Positive 4. For what x value this factor is 0? Negative 1/2, which we had earlier. Now, we use these two numbers to divide our number line. So, you draw a number line, negative infinity, positive infinity. So we have 4 here, negative 1/2 here. So we have these 3 intervals. We have to find the correct interval as our solution. Now, before you check for the interval, you have to check for these real zeros. Now, are these two solutions for our inequality? It depends on our inequality sign. So there is no equals to, means these two are not solutions. So open circle, open circle. This is our polynomial inequality. Okay, so we have strictly less than sign, means open circle for these non-zeros. Now you take a number from each interval and you test. Now what number do you want to pick here? So let's pick a negative 2. Now each negative 2 solution for our inequality. So negative 2 minus 4, that's minus 6. 2 times negative 2, negative 4 plus 1. Negative 3 times negative 6, that is 18. 18 is less than 0. That is false, right? So this is not solution. Now here let's pick 0. It doesn't matter, okay, if you use this inequality or this inequality. They both are exactly same. They are in a different form. Now, is a 0 solution? So, 0 minus 4 is minus 4. 0 plus 1, 1. So, minus 4 times 1. Minus 4 less than 0. That's true. So, this is our solution. Now, let's take 5. 5 minus 4, 1. That's 10 plus 1, 11 times 1, 11 less than 0. That's false. So our solution is green region. So from negative 1/2 to 4 is the solution for this inequality. So this is how we solve our polynomial inequality. You have, okay. Okay, do you have any question for this one? Now, let me do number 14, and after that, I want you to do number 12 and 13, okay? Before that, let me do number 14. That's page number 5. So, number 14, what we have here? We have a rational inequality, okay? Step is very similar. At first, we make 0 in one side, which we already have. Next step is we factorize numerator and denominator. So we have to factorize numerator, we have to factorize denominator. So how do we factorize 2x plus 4? Can we factorize? So we have a 2 as a common factor, right? So let's factor out 2. So if you factor out 2 from 2x, we have x. If you factor out 2 from positive 4, we have positive 2 divided by. Now for our denominator, we use a FOIL. This is a quadratic. X is the first term. Now can we find a two number whose product is negative 6 and sum is positive 1? 3. Which one is negative? 3 has to be positive, 2 has to be negative, right? Greater than 0. We have the factors. Now we find the zeros for each factor. So for what x value this factor is 0? Negative 2. For what x value this factor is 0? Negative 3. And for what x value this factor is 0? Positive 2. Now we use these three numbers to divide our number line. So you draw a number line. So negative infinity, positive infinity. So positive 2 has to be on the right side. Negative 2 is here. Negative 3 is here. So we have one interval. This is our second interval. This is our third interval. And we have 4 intervals. Okay. Now before you test your intervals, we have to check whether these zeros are solution or not. Now let's start with the zeros of denominator. Are these two solution for this inequality? These two are never solution. Okay. If you have a rational inequalities, the number that make denominator 0 are never solution. So we have open circle at negative 3 and positive 2. So open circle at negative 3 and at positive 2. Now what about negative 2? Now it depends on our inequality sign. There is no equals to sign, means this is not a solution. Now the next, we take a number from each interval and test that number. Okay, so let's pick negative 4 from here. Now each negative 4 solution for our inequality. You replace every x by negative 4. So negative 4 plus 2 is negative 2 times 2 is negative 4. So we have negative 4 here. Negative 4 plus 3, negative 1. Negative 4, negative 2, negative 6 times negative 1, positive 6. And what we had here? So we have positive 6 here. Negative 4 plus 2, negative 2, so negative 4. So negative 4 divided by 6 greater than 0. True or false? So negative 4 divided by 6 greater than 0. That's false, right? Negative number is not a greater, so this is not solution. Now let's take number from here. So let's take negative 2.5. Now each negative 2.5 solution for our inequality. You replace every x of this inequality by negative 2.5. Okay, so let me write here. So in the numerator we have 2 times negative 2.5 plus 2, that is negative 0.5, divided by negative 2.5 plus 3, that is positive 0.5, negative 2.5, negative 2, that is negative 4.5. Okay, now is this greater than 0? That's our target. So 2 times, that is negative 1 divided by, okay, what is this? So we get some negative number, right? So negative number divided by negative number is greater than 0. So we get positive number. Now is positive number greater than 0? Positive numbers are greater than 0, right? It means this is the solution. Now from here let's test 0. So we have 0 plus 2, that's 4, 0 plus 3, 0 minus 2. So we get negative number. So this is not solution. So let me pick 3. 3 plus 2, 5, 3 plus 3, 6. Okay, we get positive number which is greater than 0. So our solution is the green interval and this purple. Okay, so from negative 3 to negative 2, parenthesis, or from 2 to positive infinity. So this is our solution for these rational inequalities.